Hello, everybody. We're going to do single linear regression using RStudio today. To do this, we need a data set. So let's together load in a data set. To load in any data set, you want to call it a name. I would call it a name of what you're working on. I'm working on movie file, so I'm going to call it the movie one file. The only reason I put a one after it is because RStudio has a lot of built-in files, and I want to make sure I don't accidentally load in a file that was already in there. So I put a one after it in hopes that there's nothing called movie one. So movie one, and actually it's not movie, so moving one will be this file. And so to name the file, or sorry, not name the file, to find the file, we're going to use read CSV file dot choose, open close parentheses, header equals true. And what happens is it should bring up this prompt box saying, where do you want me to find the file? If you've written the code correctly, which is down there in the bottom left, you should find this file or the file you're looking for. I have two of them. I have the CSV file and I have the Excel file. Because it's read.csv, I've got to make sure it is the CSV file or else we are not going to get any good work done. Please make sure it is the CSV file as it says. So we load it. Beautiful. And it pops up here. Moving one, 36 observations. So there is 36 deep, 36 rows, 4 columns of data. You'll notice I have other data sets in here too. I've been playing around with other things prior to this class. So moving one. After this, I like to do some things to make sure that my data set is correct. So I attach. Now sometimes you get things like this. If you've already been using a data set that uses the column titles of elevator, feet, hours, and large, like I did here, it's going to say, wait a minute, you were using this in this file called move one. You're now doing this new file called moving one. We are now masking those names for move one into the moving one. And that is good, that is proper, no issues there. If you're worried you don't have the right data, you can always ask it to show the first few values of the data set. And so I like to do this anyways to see what has been scanned in by RStudio. And there you go. I see 4 columns of data. I see hours. So this would be labor hours. So you have to understand your data set, right? Before you do anything else, you have to understand your data set. So my data set is labor hours needed for moving cubic feet of boxes from an apartment. So we're a moving company. And what we have is a certain amount of boxes in cubic feet and how many hours it takes us to move them. These two variables we will not be using until we get to the multiple regression section. We'll come back to these variables. This will be the number of large boxes that we move and whether there was an elevator at the apartment or not. So right now I'm going to focus on these two. The cubic feet I have to move. The owner has this amount of cubic feet and the hours it took me. So this is my sample data set for my moving company. And really I want to know, can I predict hours from feet moved? That's really what I want to know. Can I predict hours from feet moved? That's very important to me to know which one I'm predicting because that'll be my Y value. I always need to know what is my Y value, what is my independent, what I'm plugging in, what is my dependent, what is coming out, what am I predicting as I call it, my hours. Got it. That's very important to me. So by the way, I have a Word file open. And what I like to do, let's call it moving example, is when I'm working on my stuff, I like to save my R code in a Word file. The reason I do this is to never have to type it again. Though I'm typing it in the illustration, I don't want to type this again. I'm just copy and paste. So now what I want to do, now that I have the code written perfectly, I can just copy and paste this into R. No issues. Also, I can make little comments to what everything means in this command line. It's very important to me when I'm looking back going, all right, what does it mean to be a CSV? Well, this means I'm reading in a CSV file. So if I don't have a CSV file, I'm in trouble. File.choose allows me to pick the file I want. And that's important to me. Unless you know the direct path, and then you can use that. And header equals true means I have headers. I have row headers. I like to do this because I like to know when I look back on my code what I'm doing. I'm going to change, that's not that, I want this one. I want to change that to black because those are my notes. I like to know what each and every line does. So that way I can look back on old code and use this kind of I want to call it quote unquote a cheat guide, but hey, it's my user manual. That's really what it is my R user manual. And for each thing, and if you want to copy down the other information, that's fine too. So in your example, you can have that. I would particularly do this if you were a student. That way, again, you can address what it means, and if you need to run it again, you can look at it. Excellent. And that's the way I'm teaching this in terms of if you were a student learning to do linear regression in RStudio, in case you're wondering. So now that we have this loaded, I would like to do a quick scatter plot. Well, there's where the plot command comes in. The plot command is x comma y. That's why, once again, we need to know what's x and what is y. In this case, our x, as we mentioned, was feet, and our y, as we mentioned, was hours. So we plot, and if you notice, on the right-hand side of the RStudio screen, out pops the plot we were looking for. And so we have a nice plot of feet versus hours. And I do a first initial scan to see if linear regression makes sense. That is, if I can imagine a line shooting through all those dots, would it make sense? And right now it does. There's no major bend. If there was a major bend, I would do some type of transformation. We'll talk about those later when we talk about transformations. If I have any unusual points, like these two, I might want to investigate them, and we will. We will definitely investigate them when we do the residual analysis. That might be in part 2 of this video. So we are looking at a really good linear regression here. So I'm going to continue on with my analysis. Because I like this plot, once again, copy, bring it over to my Word, paste it, and yes, you can even paste. Oh, sorry, these are notes. That's not what we want. Where's my RStudio? There it is. I can even paste this. The way you do it is you export. The way I do it is copy to clipboard, and I make a copy of this plot to bring to my Word file. There are other ways. Please look into that. This is just a quick, easy way for me to have what, again, each one of these command line does, so that way I can repeat the procedure down the road at my leisure. Excellent. So again, the plot looks nice. I can quickly run the correlation coefficient by just doing correlation of x comma y, and I see I get a 0.94299. That number, let me do hashtag. Now, hashtag in RStudio is for you to write comments. So if you wanted to write a comment to yourself right now, you could do hashtag. This correlation value is above 0.6, and so we have a strong linear correlation. Typically, if you're above 0.6, it is a strong linear correlation. I would recommend talking to your professor or to your manager to see what number they use. I'm going with the number that's typically used in most stats books. And so, all right, cool. We have the correlation number now. Of course, it would be nice to look at the prediction line. To run the prediction line, we have to run the command lm. So how does one do that? Well, first, you got to name it something. So in this case, since we're doing moving, I'm going to call it moving line 1. And by the way, to put anything into a file, that's what this arrow does. This arrow loads it into this name. That's what this arrow is, a computer science arrow. It says whatever I'm about to type, load it into move line 1. And so the command for a prediction line, at least a linear one, is LM. LM stands for linear model. So LM of, now you need to have y tilde x. And so that's the easiest, most generic way to create a linear model is to do y tilde x. Boom. It creates it. It populates it up here. Movie line 1, list of 12, and there are 12 pairings. And so we can run a summary on move line 1. And what we have here is the following. You see, we are looking at the summary analysis for the movie line, the prediction line. And there's a couple of key things I want to talk about. Again, what you should be doing is after each thing works, you should be copying and pasting it over and inserting your notes onto what each one means. I'm going to pause doing that now for time's sake. But I want to make some quick comments in my comment section. Again, you can make quick comments by using the pound sign or the hashtag, as you guys call it. First of all, if somebody wants the linear regression equation, the prediction line, that is y hat equals, and you find it right here. These are the coefficients on the slope and the coefficient on the intercept. So my prediction equation is 0.05x minus 2.37 to 2 decimals. And that's my prediction equation, my linear regression line. Of course, it's always good to understand what you're doing. The slope means what? All right, the slope, by the way, the slope, which is 0.5, means what? Means that if we increase x, which in this case, x is played by cubic feet. If we increase x by 1 unit, so by 1 unit, so 1 cubic foot, then our y, which is labor hours, increases by 0.05 hours. It's important to have a good concept of what everything means in here. By the way, if you're looking to see, hashtag, if you have a significant linear relationship, you can run the t-test on the slope. The good news is that we have this. The t-value equals 16.52 and the p-value is 0. How do I know this? Well, again, let's look up here. The t-value is 16.522 and the p-value, the probability greater than t, is 0. It's triple star. What this means is it is a very significant variable. The slope is a very significant variable according to the t-test. What this means is I reject the typical null hypothesis, and our slope is significant. And that's good news. That's good to know. One last little comment I'll make in this video, and then we'll continue in part 2, is the r squared value. The r squared, again, can be found with multiple r squared. Please do not use the adjusted r squared until multiple regression, but right now the multiple r squared is 88.92%. And that means 88% of the reason y varies is due to the variation in x. So in this example, we have the main reason why labor hours varies. It's because of the cubic feet we moved. Thank you guys, and I hope you watch our second video.